Welcome back. We're going to go over rules and formulas 3 next. And rules and formulas, all the rules and formulas, they they have a lot of different topics in them. So again, I don't want you to feel overwhelmed when you're looking at all these different rules. Um, it Do your best to memorize them all. Um, Most likely you'll get one question at least from each of these. So in rules and formulas 3, we're going to cover the unit circle, just some basic information on the unit circle. We're going to go over ratios of length, ratios of area, and ratios of volume. Ratios of length is pretty simple, but when we get into area and volume, we have to start comparing squared and cubed amounts. The Pythagorean triples have to do with 90-degree triangles. And it's good to memorize a few of these that can help you with the Pythagorean theorem. FOIL and distribution, I think that's going to be probably pretty simple for most people. The FOIL method is just multiplying two binomials like x plus 5 times x minus 3. And then you would multiply those. That's FOIL. That's the FOIL method when you multiply it out. You multiply all four of those. And then the number of solutions, that has to do with this. This could be talking about number of solutions with systems of equations, or it could be talking about how many solutions do we have on a function. So how many times does the function cross the x-axis? So we'll take a look at that and at the end here. So starting with the unit circle. The unit circle has to do with trigonometric ratios. And when you first see the unit circle, it can look a little bit overwhelming. There's a lot of information on it. So this diagram, we're gonna go over this last. But let's look at the unit circle and see if we can look at some patterns or some basic information on the unit circle. So here we start at 0 degrees on the unit circle. When we go around the circle, we go around counterclockwise. Um, you might be thinking, well, clockwise makes a little more sense, but counterclockwise is the rule. So we go backwards counterclockwise. Think of it backwards as the clock ticks. Um, and then the degrees, these are the degrees from the center. So from here is at 0. And then so right here, this would be a 30-degree angle. Now, all these things that say pi on them, those are radians. Radians is another way to express an angle measure. So when we talk about using trigonometry with sine, cosine, and tangent, it's important that we have everything in degrees in our calculator because a lot of these problems are going to ask you for the answer in degrees. So sine is, if you remember the acronym SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Let's scoot this over here. Opposite over adjacent. So if we have a triangle, like something like this, I'm just going to say this is a 30-degree triangle. We'll say the hypotenuse is 1. And well, if we let's see here. So we're trying to make sure this is a true statement if I put another number here. So I'm just going to leave this at 1 for now. So if we wanted to know sine of angle 30, I'm going to call this y. Sine of 30 degrees is opposite over hypotenuse. We would write this as y over 1 is the hypotenuse. And we could solve for what y is. So sine of 30 is y over 1 is just y. And so we could type in sine of 30 in our calculator, and it would tell us that it's y is equal to 0.5 or 1/2. When I say 1/2. So um, the opposite over hypotenuse is sine. So on the unit circle, this is equal to 1 always on the unit circle. And so if we say this is 30 degrees, this 1/2 corresponds to this y coordinate on our unit circle. So all of these are, you can think of sine as being what y is on the unit circle. So that's sine, 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 and so on. All of these coordinates, all the x coordinates are cosine. So these are all the x coordinates. And we can actually figure out how tall all of these triangles are using the unit circle. So if y is equal to 1/2, we're going to just write 1/2 like this. Then sine of 30 is 1/2 over 1. Because it's y over 1, and 1/2 over 1 is just 1/2. So that's how we get the 1/2. Basically, we just write this radius equal to 1 to save us some time, because it's really easy to divide by 1. So that's where all these numbers are coming from, is pretty much what I want you guys to memorize. So these aren't just randomly on here. They have to do with a radius of 1. Those are the x coordinates. Those are the y coordinates. And we can figure out any angle, but they just tell us for 30, 45, 60, 90. And then it continues down to 180 and then back to 360. If you notice there's a pattern for all the y's, it's 1/2 root 2 over 2, root 3 over 2, and it goes up by 30, 45, 60. Some students memorize this. If you have time to memorize this, I would suggest memorizing it. Because once you know this part, if you know these three, you can figure out the other ones intuitively. So what I mean by that is you can say, okay, well, if we went over from 60 degrees to 120 degrees, then our y-axis or our y coordinate didn't change. So we can just leave root 3 over 2 on both of those. But it's a mirror image of our x. So then instead of it being 1/2, it's going to be negative 1/2. And also because we're now over here on the x-axis into the negatives. And so the pattern is going to repeat itself. And so if you know the first three, you can start to figure out the pattern for the rest. But because we have so much other information to go over, I'm going to kind of pause there, and we're just going to go to the next slide here. Okay. One more thing. If you notice, these all have radians on them. So pi over 6 radians is equal to 30 degrees. The easiest one to remember is that pi radians equals 180 degrees. And also 2 pi radians equals 360 degrees. But now, if you know this, you can write a ratio of degrees and radians so that you can change degrees to radians and vice versa. So let's look at this next problem. It looks like it tells us the radians in this next problem. It says if x is pi over 3 radians, what's the value of cosine x? So let's see if we can actually find pi over 3 radians on the unit circle. You don't get the unit circle on your test. So pi over 3, I think it's more challenging to memorize these, because that's radians, I think it's a lot easier to memorize the degrees of how much that it goes up by on the degrees. So it goes 30, 45, 60. So it jumps by 30, 15, 15, and then another 30. 30, 15, 15, and another 30, 30, 15, 15, and another 30. So if you know that pattern, then you'll know which one of these that we're on. So it says cosine of pi over 3. So that's cosine of 60. Now, if you don't have the unit circle and you have to figure out what pi over 3 radians is, you can do that too. So you can say pi over 3 radians times, I'm going to get rid of the r though for the radians for now, times, now we're just going to multiply by 1, but it's going to be a ratio of two different values. So it's going to be 180 degrees over pi radians. So 180 over pi equals 1. So we can multiply pi over 3 times 1 and still get the same answer. So for all of these, we either have to multiply by 180 over pi or pi over 180 to get our units changed from radians to degrees or from degrees to radians. So when we do that, now the pi's cancel and we get 180 over 3, and that's 60 degrees. Okay, so we found out that's 60 degrees. That's great. But now it says, what's the value of cosine of 60? Well, this one you could check in your calculator without even needing to really do the unit circle. So you could just type in now, you can say cosine 60, make sure your calculator is in degrees, and it's going to tell you 0.5. So A is our answer for that one. Now, if the answer was something like a square root, whatever your answer is on the calculator, you could type these in and do a guess and check. So you could press equals, and this would give you a decimal, a rough estimation of a decimal if you needed to check those also. This one was a little easier though, because the answer was just 1/2. Okay, so that's how you would check that. You can just change these to decimals in your calculator and then see if they match up. So all I did was I did cosine of 60, and that gave us our answer for that one. And then these I'm just putting in the calculator and writing the decimal equivalent that they're about equal to. All right, so that was kind of a lot on the unit circle. But again, this is just a quick overview on what the unit circle is. So I don't want you to feel too overwhelmed about the unit circle. I really think it's important that you know sine, cosine, tangent. You know the rules of SOHCAHTOA, or how to calculate sine, cosine, and tangent. And also that you know how to use degrees on your calculator. And finally, that you can convert radians to degrees like we did here. If you know how to do those three things, or if you know how to do all of those things, you should be good with most of the trigonometry section on the SAT. Okay. So now we're going to go over ratios for length, area, and volume. We can talk about the ratios based on these three different properties. So for this small triangle or this small rectangle going to the larger one, if we look at just the side length, this is 3, this is 15. That means we had to multiply by 5, or we say that is a scale factor of 5 or a common ratio of 5. And we'd also have to check the other side to make sure that 7 times 5 equals 35, and it does. Now, for for the for the area though, we're going to say that it's 5 squared. So whatever the side length is, we're going to square it. If we're talking about volume, we've got to cube it. So that's really important. A lot of students, they just use the common ratio 5 with area problems, and then they'll end up getting those incorrect. So let's look at an example. It says the radius of circle G is 9 times the radius of circle H. The area of circle G is how many times greater than the area of circle H? So we have our circle. We're talking about the radius. That's 9, or excuse me, it's 9 times the radius of circle H. So this is, we can say this is circle G. Circle H is much smaller. And we'll just call this X, and this is 9X. So how many times greater is it? We're talking about the area. It's 9 times greater for this radius, but the area itself is going to be 9 squared times of a difference. So 81 is going to be our answer. 9 squared is 81. Okay, let's see if we have another one. No. Okay, Pythagorean triples. These are right triangles that have a whole number on them. So if you're trying to use a right triangle and you need some information of what would make a right triangle, these are the most common ones. We have 3, 4, 5, 6, 8, 10, 9, 12, 15, 5, 12, 13. If you can remember these 4, you should be good to go. I think these two are used probably the most often. So you'll need them for the Pythagorean theorem for some Pythagorean theorem problems. So let's look at an example here. It says, what's the perimeter of this trapezoid ABCD? So the perimeter, we've got to figure out what this is. And that's the same as that. We know that from here to here is 20, because 20 is up here from AB, and that means that's 5. So if we know our Pythagorean triples, we'll go back up here to our list. 5, 12, 13 is a Pythagorean triple. And so we have a 5, and this is 12. Now we could also figure that out with the Pythagorean theorem. We could call this B. Pythagorean theorem is A squared plus B squared equals C squared. So 5 squared plus B squared equals 13 squared. 25 plus B squared equals 169. And then subtract B squared equals 144. B equals 12. Do the square root of both sides. So that's just going to take you more time if you don't know the Pythagorean triples. So now we know this is 12, and that means this is 12. Now we can figure out the perimeter much more easily. Get rid of this stuff. And 20 plus 25 plus 12 plus 13 is 25 plus 25 plus 20 is 70. So you can just use the Pythagorean theorem, but if you know those Pythagorean triples, it could save you some time on some of the questions. Okay, the FOIL method. I think most people know how to do the FOIL method. It stands for first, outer, inner, last. This is just basic multiplication of a binomial. So just remember you do all 4. You do all 4 of these. I like to start with that. I usually do first, last, outer, inner. That's how I do it. But anyways, you just multiply that times that, that times that, that times that, and that times that. You make sure all 4 numbers get multiplied, and you should have 4 terms when you multiply it. If there's a minus, make sure the minus goes in the right spot, and then just combine the like terms, and you should be good to go. We'll do one example here. It says, which of the following is equivalent to x cubed plus 10x cubed plus 25? Okay, so when you have a squared like this, you cannot just bring it there and then. A lot of students do that. You can't do that. And you can't just bring that there and there. This says quantity squared. So this actually is x cubed plus 5, the quantity x cubed plus 5 times quantity x cubed plus 5. Then we do FOIL method. So those first two, that's x to the 6 plus 5x cubed plus 5x cubed plus 25. Let's see if I did that right. X cubed. I think I just did the entire problem. Yeah, so I did x cubed times x cubed is x to the 6th. X cubed times 5 is 5x cubed. Then I did this next part over here just from force of habit. So 5x cubed again, and then 5 times 5 is 25. And then we combine the like terms. Okay, so it looks like x to the 6th. It looks like uh, 1 is equal to that. Now let's check 2 though, because it could be. So let's check 2. This one says, this one in a different color, x squared plus 5 times x squared plus 5. Well, these are all the quantity of times the quantity x squared plus 5. Okay, so now we're going to do the same thing. That's x to the 4th. That's plus 5x squared. Again, plus 5x squared. And then plus 25. And we haven't done anything with this third binomial. I'm just going to write it to the side here. Okay, so now this is x to the 4th plus 10x to the 4th plus 25. And that's x squared plus 5. Now this gets a little bit tougher because we've got 3 terms now, but we basically do the same thing. So you just do that times that to start with. So x to the 4th times x squared is x to the 6th. X to the 4th times 5 is plus 5x to the 4th. Then we do the next term times these two. 10x to the 4th times x squared is 10x to the 6th. And remember, we're adding exponents when we multiply. When we multiply exponents, we add them if they have the same base. And so this has the same base of x. Even though there's a 10, the 10 just stays there, 10 times 1. So 10x to the 6th. 10x to the 4th times 5 is plus 50x to the 4th. And then the very last one I'm going to do in red because there's a lot of stuff on here. So those two are the last ones. I'll just keep writing it in blue here. So plus 25x squared plus 25 times 5 is 125. Okay, now we got to combine all these like terms. It looks like we're not going to get this because we've got x to the 4ths, and that's not in here. And then 10x to the 6th plus x, that's 11x to the 6th. So there's no way that that's it. But I'm just going to finish this problem anyway because we're almost done with it. So 11x to the 6th, and then I would just cross these out and go from the highest to the lowest power when you can. 55x to the 4th, cross those out, plus 25x squared, cross that out, plus 125. So there's no way that equation 2 is. It's just going to be 1. Okay, so that's how to do FOIL with binomials. And when we have 3 binomials we're multiplying, it gets a little bit trickier, but it's still possible. Okay, you could also, let's see, you could also type this in Desmos and you could say y equals all this. And then you could do the same thing. Y equals that, see if you get the same line. Y equals that, see if you get the same line. So if you do get the same line, then they're equal. If you don't, then they're not. Okay, and this is all the steps here. I might have made a small error here. 25x. Well, if I did make an error, then we can go back and you can go back and look here at how to do that. But uh, let's not focus too much on the binomials times three. We really don't see this very often written this way. Um, but if you can find one of my mistakes or you find the error, please let me know. But we're going to move forward and go to number of solutions next. So the number of solutions for two linear equations. Um, this just has to do with systems of equations. So if they're the same line, they have infinite solutions. If they have the same slope, but they're parallel and they're not the same line, then there's no solution. And if they cross at one point, so they don't have the same slope, and they cross at one point, they have one solution. I think we went over this several times with systems of equations in the past. So here they give us an equation. It says the equation above is one of the two equations in the system, and it says the system has one solution. Which one of these could be the second equation? So A, definitely not A. That's the same equation, same two equations. That would be infinite. We're looking for one that has one solution only. For these other ones, for D, I would say first let's change that so we can figure out what 1y is. And I just jumped to D because it's in a different format. So if we divide by 4 and divide by 4, we get 3/4 x minus 2. And that's actually the same thing as A. So it's not A and it's not D. Now we've got pretty good odds of getting the right answer here. This next one, B, has the same slope, different y-intercept. So that means that it's going up 3/4, starting at -2 on the one they give us. So it's like that. And then for answer choice B, same slope, but it's starting at -6. So it's like the same slope like that. That's parallel. So that means there's no solutions. So it's got to be C. So if we go back, go at C, -2 is the y-intercept for our second one, and then we go down 3/4. So like this. And I'm just doing a quick estimation. You can always use Desmos to check if you need to. But there is just one solution for C. Okay, correct answer is C. And I believe that's everything for our rules and formulas. Okay, so again, let me see if we can just go back here. Let's see if see what I did wrong here, because I feel really bad for not giving you guys the right information here if that's not the right answer. So I just want to double check this. X to the fourth, X to the sixth, and that's plus 5x to the fourth. Got that. Plus 10x. Ah, that's where I made my mistake. This was 10x to the fourth. Let me go back. So if you already found that, that's awesome. It's going to erase these. You found that earlier. Thank you for doing that. This was supposed to be 10x to the fourth. So when I added these 5x squareds together, I put 10x to the fourth, but that's 10x squared. 10x squared times x squared is 10x to the fourth. And then that messed up a lot of other calculations also. Let's see if I made any other mistakes on here. So that's not good to have errors in the algebra. 10x to the fourth, 50x to the fourth. So that second term was wrong also because I made it to the fourth because that 10x was supposed to be a 10x squared. So that's 50x squared. Okay, I think that solved the rest of our problem there. I think that was just the one error that there was there. Let me see. Plus 25x squared plus 125. Yeah. So there's that, just that one error made a huge difference in our answer. So now let's combine these like terms again. I know the answer is still A here, but let's just go back and make sure we have the right answer written down. Plus 5x. Let's see, this is 15x to the fourth. Yep. Okay, 15x to the fourth. So got those done. That one's done. Plus 75x squared. Those crossed out. Plus 125. Okay, so again, 5x squared plus 5x squared. It's 10x squared, not 10x to the fourth. All right, so that's everything for rules and formulas 3.